Hi. Okay. So today I want to demonstrate how to use this system that I created for the research model module. Basically the whole idea here is demonstrating how to use probabilistic sampling techniques to students. So how I would approach the lesson, basically from this using this system, right, as an introduction. Of course, I would structure it in a way that the students need to engage with the system themselves and see if they can make inferences from what they are experiencing, right? That'll be a good way to actually, solidify the knowledge in their brains. So, so basically, what actually happens here? So the idea is sampling, right? Sampling techniques. When you're involved in research, an important component to research is sampling, right? Being able to collect data, right? You cannot collect all the data. You can only collect a fraction of the data, and the fraction, the sample size is determined by other probabilist, other statistical factors, so to speak. So in this case here, we're demonstrating probabilistic sampling techniques. When you're stricken with a choice to make, whether your research might want probabilistic, if your research is empirical, I'm guessing these are some sampling techniques that you would actually look into for collecting your data, right? But if your research is not empirical, then you could use non-probabilistic sampling techniques. But today I want to demonstrate probabilistic sampling techniques and how they work, right? So the first one is simple random sampling. The second one is systematic sample. The third one is stratified sampling, and the fourth one is cluster sampling, right? So today I'm going to demonstrate all these four sampling techniques, and then I'll just take you through the introduction or just the basic knowledge of it, and how I integrate this the book. So we'll start by selecting a simple random sampling, and we'll click on populate because now we need to generate a population, and we want to say, okay, let's make our population 50, right? And then we have 50 members in our population. So this is all the data you could collect, but in the real world, you cannot collect 50. You cannot collect all the data that's available, right? The whole idea is to try and sample closely to the population size, but it's usually never the case, right? So that's why we use sampling for to help us with that. So now let's say in this case, then we could only collect five, right? Five. We can only collect five samples from the population. According to this is again, the reason for this is it could be a plethora of reasons, right? It could be because resources and things like that. So here we're trying to simulate a situation where you can only collect five. You can only collect five sample members from a population of 50 because to limitless constraints. So in this case here, so what's happening here? So now the system, as you can see now, has generated its own sample, right, from the population. And this sample here, the numbers that you see below each and every sample is basically the points that each and every population member has attached to it. So basically, the system here, we're trying to go against the system sample, right? This is the system sample, and then the number of points that it has. So it basically added everything here, and it got to 19, right? You can confirm it. This is 10. Wait. This is 10. This is 10. No, it's not 10, sorry. This is 5, 9, 10, 15, 19. Yes, it's 19 points. So the whole idea is using simple random sampling, you should be able to generate um, a sample from the population that can challenge 19, right? So you're going to use that. So the whole idea here is that we're using probability. Probability is at the center of selecting each and every member, right? You don't have control over, let's say maybe you want to select all fives, you don't have control over that, right? Because the whole idea is to remove your biases out of the sampling methods. So in this case, right, yeah, we have a sample of five, da, 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 da. How we select our population then is by spinning the wheel here in the middle, by clicking the space bar on our keyboard. And then it'll keep on spinning until we let go, right? So let's hope here we get, the whole idea is for us to get uh, five population members. So it's selected three. So our first one is two. It's this one, right? And it won't be removed for the simple fact that each and every member in this population using under this particular sampling technique needs to have an equal amount. The probability of selecting each and every member should be the same, essentially. So that's the first one. We've selected the first one. Now we're going to spin again. Then we're going to select the second one. Let's see what we get now. We get 28. So you'd count is 14, 21, 22, 23, 24, 25, 26, 27, 28. So 28 is just behind the wheel there. I don't know what number it is, but we'll see it. Oh, yeah, we cannot even see it. But yeah. Okay, that's the second one. Now, so we're selecting the third one here. The third one here is 6, which is basically a 4. Looking not very hopeful, but yeah, let's hope that it'll be okay. Let's see. Okay, 31. Okay, and that's our sample. If we counted ourselves, right, 4, 8, 12, 14, and then because it's 12 is 14. So basically the system and the user are gonna draw here, right? So you can choose to challenge the system, or you can choose to re-sample again by clicking on random sampling technique and then spinning, right? You're gonna have to spin 5 times, and it's gonna replace the current 5 that you have here. I guess maybe that's a feature that we need to do. We need to be cognizant of. We need to remove this when you're actually spinning to help. Third one. Okay. Okay, so it's done. So let's see now. Now we have selected, let's see. This looks like it's less, yeah? It looks like it's less. We're going to lose. So let's just try it again. Okay, 35 is the first one. Okay, so 16 is the second one. 32 is the third one. 25 is the fourth one. And let's see, the last one would be lucky number 37. So yeah, now we have our new, so it's 1, 2, 3, that's 3, 7, 8, 9, 9 plus 4, that's 14, still falling up short. So if we challenge the system in this case, the system wins, right? So the whole idea was to now try and get sample members with a high population, but you'll realize soon, right? Like with probabilistic with probabilistic sampling techniques, you don't have control over that. The whole idea is to remove your biases from the process of sampling, right? So yeah, you may not get the winning sample, but the whole idea is that you don't have control over, the sample, right? But let's say now you want to have a bit of control over the sample, right? What do you do then? From here, maybe let's try uh, systematic sampling techniques. Or okay, before that, let me just maybe create a new population. Uh, Again, we want to keep it at 50. Okay, for this case, I'm going to say 100 because yeah, it's going to help us in actually playing around. Let's say yeah, let's play around with 10, right? So the system generates 10. Its point is 26, right? So now we've selected a systematic sampling technique. So this method here is basically saying, okay, I'm gonna label my I'm gonna label my population that I have. I'm gonna label it one or A, B, C, D, E, F, G, whatever. But most preferably, the system in this case does it with numbers. It's easier for it to track, right? So each and every population member has a number attached to it. So in this case, this element here or this member here is actually one and counting, right? So it's this is one, this is two, this is three, this is four. So the numbers are basically identification numbers, but then they're incremental. So this is one, two, three, four, five, six, seven, eight, nine, 10, and so on and so forth, right? So the idea here is now with our systematic sampling, right? The idea is to say I'm going to select an nth term. So each and every number, identity number that is divisible by the nth term is will be selected, right? So what do I mean by this? I'm gonna spin, right? And I'll let you know. Let's see what number do we get. This number that we're selecting here is our nth term. So our nth term in this case was 79, right? So 79 was like is our nth term, right? But if you say 79 plus 79, you would probably get a number outside of 100, outside of a population number. So from the population, if our nth term is 90, is 79, that means we only have one sample, right? So I'm going to click on it again and try and get a lower sampling nth term, sorry. And let's see if we can. I hope it'll work this time around. 70, no, does not cut it for me because now I'm challenging 26. So I'd rather, I have to really get a small number. So you see 30, 38, yes, because 38, it'll give you 60 plus 16, that's 76. So 76 is the second one. This is 76 is 30, 38, this is 76. So no, still not enough. Let's spin again. 52, right? Still not enough. Oh, really hard to get that small number, eh? What must we do? 38 again. Not enough. Let me try and spin it really loud. Let's see. I'm praying that I get a number below 10. Or even 10 itself will actually do us a great favor here. Oh my god. Let's try it again. Oh my god. Probability. See, you don't have control over, and it's really frustrating. But that's the whole idea, right? The whole idea is it all has to be in the hands of probability. It's 18, not bad, but challenging this, we'll probably lose. Let's see, this is 8, 10, 15, 15, 16, 17, 17. 17 won't challenge that. And I'm scared to say if I continue trying, I'm going to get a bigger number than 18, but let's try, we never know. 21, let's try again. 70, started again with these unfortunate numbers. Okay, 14. Let's see. 14 has given us 2, 4, 6, 7, 7 elements. And do you think it's going to challenge this? No, no way. Challenge, the system wins. You've been beaten by the system. But again, the idea here, I think you kind of get it. The idea is to get a very small nth term that's going to help you select more members in the sum. So in this case, the number you may actually run into one, right, and literally select the whole population to challenge the system, and that would be fair, right? Because again, it's the nth term. So with systematic sampling, the sample size does not really influence whatever you get. Like as you saw, we're able to get one, member in our sampling in our sample, right? So that's okay as well. But the whole idea is the nth term, and then it's all probability. The selecting of the nth term has to be, probabilistic in its own, right? So I'm going to move on to sampling using stratified sampling. So I'm going to select the population as well. I think in this case, let me just make it 50 because I don't want it to mess up the screen. So we need to please select a bias for stratified. So we need to discriminate the population that we've created. So I'm gonna say okay, population of a sample size of 5, just to make it quicker, right? But you can play around with different numbers as well. So in this case, I'm gonna click on this red drop down. It's basically gonna open a model that we can actually choose. So now what we see here, size and color, are attributes that we can discriminate the population here with. So we can either say color or size, or we can say the head. So if you see, right, the population has different heads. There's others with stars, others with boxes, and I'm gonna discriminate them using that. Let me see if yeah, let me just type it in as well. Head, da. So now you see, now what has happened is the population has been divided into four, right? Circle heads, star heads, square heads, and I think it's hexagon heads as well, if not octagons. I don't know how many sides. Let me just count: one, two, three, four, five, six, six. Yeah, hexagons. So no problem. From there, what happens is now whenever you spin the wheel, right, you'll be selecting from the different strats, right? So this jar here, this jar here, this jar here represents a strat. The population, the system has generated its own, and it has 15 points. So the challenge is to try and challenge the system to get more points than that. So let's see. But but in this case, you can only have five. Um, five. You can only have a sample size of five, right? So we're gonna spin, and whatever number we get is basically going to select from that particular jar. So in this case, as you can see, it's 40, right? So it's 40 divided by 4. Not 40 divided by 4 per se, but it's 40 modulus 4. So it's basically the remainder has to be 0, right? Let me see. Let me just cross check it. I just need a scientific calculator. Scientific. 40 modulus. I'm using my phone here, and I don't think I have that feature here. But there's no problem. What we'll do is just divide by 4. So yeah, so the remainder is 2. So basically, we want to be selecting from this here. So basically, the system now has selected a member here in this particular strat. So you want to go again. Our first one has come from here. So remember, the first one has to be a square, and we see the second one would have to be 4, right? 4 divided by 4 is 0, right? So basically, we're selecting a hexagon in that case. So I guess the first one has to be a star, because yeah. And this, again, dividing it by 4 until you get the remainder. Realize, let me see, 48 divided by 4, divided by 4, divided by 4. Basically, the remainder is 1. So I'm guessing, yeah. Let's go again. Okay. Okay, then the last one is, let's see. So yes, so you see, the first one is a star, and then a hexagon, and a star, and a box. So basically selecting from each and every box, helping it. Let's see how many points do we have here. 2, 5, 7, 10, 15. 15 can challenge 15, yes, but then the game will result in a draw, right? So you haven't won so far, but the idea is playing around and understanding that and extrapolating from it, making inferences on the concepts of these particular, sampling techniques might give you, a good foundation on the sampling, on the probabilistic sampling methods. I hope this helped. Take care.